So in this equation, we're dividing cotangent of negative x by cosecant of negative x. And cotangent divided by cosecant, that is a quotient identity. So remember, two consecutive vertices form a quotient. So cosine is cotangent divided by cosecant on the trig hexagon. So we're going to substitute cosine of negative x for that quotient, cotangent of negative x over cosecant of negative x, and that's still equal to 1/2 on the other side. Then cosine is the reciprocal of secant, and that's important because secant is the one that has the e, and remember that reminds us that secant is an even trig function. So its reciprocal cosine must also be even. And even functions have the property such that f of negative x is equal to f of x. So cosine of negative x is equal to the cosine of x, applying that even identity. Okay, now we can use the inverse to get the x by itself. So x is the arc cosine of positive 1/2. And that's asking where on the unit circle over the interval 0 to 2 pi inclusive do we have an angle with an x coordinate of positive 1/2. And in quadrant 1, right, this is pi over 2, pi over 3, pi over 4, pi over 6, and 0 in radians. And pi over 3 is our quadrant 1 angle that has an x coordinate of 1/2. So our principal value is pi over 3. Then our acronym, all students take calculus, reminds us that cosine is also positive in quadrant 4, which means that 5 pi over 3 is also a solution. So in our calculator, we're going to check both of those answers. So in the mode, we want to make sure that we're in radian mode, which we are. And then we're going to store pi over 3 as the x. Then our equation is in the numerator cotangent. There's no button for cotangent on the calculator, so we'll use our reciprocal identity 1 over the tangent. And that is being divided by the cosecant. And since we don't have a button for cosecant, we're going to use the reciprocal identity again, 1 over sine. And we're checking that that is equal to 1/2. So we press enter, we get back a 1, which means that pi over 3 checks. Now we're going to check 5 pi over 3. And we can arrow right back up to that equation so we don't have to enter it again. And we get a 1, which means 5 pi over 3 also checks.